You know, every once in a while, a research paper drops that doesn't just talk about a slightly better model. Nope. It hints at a completely new way of building AI. And that is exactly what we're looking at today with a new paper from the Chinese AI lab, DeepSeek. They might have just cracked the code on how to make AI smarter, not just bigger. And this is where it all kicked off. A single post on Reddit that just lit a fire under the AI community. Look at that freezing, a fundamental improvement. That is a massive claim. It's not just an update. It's a change to the very blueprint of how these huge models are put together. So, that's the big question we're going to unpack here, right? What problem are they even trying to solve? How does this new tech actually work? And, maybe most fun, we'll look at why people online are getting so excited, and in some cases, a little weird, about what it all means. Let's get into it. Okay, first things first. We need to understand the problem, because right now, the AI industry has slammed into a kind of wall. For years, the playbook has been simple. If you want a smarter AI, you just make it bigger. But that whole approach, it has a really dark side. And let's not beat around the bush here. Training these monster models has become one of the single biggest headaches in modern computing. It's not just that it's complicated, it's just so unbelievably inefficient, expensive, and resource-hungry. Yeah, this is the painful reality for so many developers. These massive training runs often just fail. They just break halfway through. And when that happens, you're not just losing some code, you're losing weeks of work, thousands of hours on super expensive GPUs, and a truly staggering amount of electricity. It's like trying to build a skyscraper that might just decide to fall over when you're halfway done. So to really get what DeepSeek did that's so clever, let's use an analogy. I want you to think of the connections inside an AI model's brain like a big highway system for information. For a long time, we've had a pretty reliable but kind of limited design. The original design was called a residual connection. Think of it like a simple one-lane country road. Information gets from point A to point B. It's stable. It works. But then came this new idea called hyper-connections, or HC. The goal here was ambitious. Let's build a massive, multi-lane superhighway. Let way more information flow through, make the model way more powerful. The problem? It was a mess. It was totally unstable. You'd get traffic jams, crashes, the signals would get all mixed up, and the whole system would just fall apart. And that is the absolute key thing to remember. In theory, HMC was a brilliant idea. Just widen the road to get more performance. But in the real world, especially as models got bigger and bigger, these uncontrolled connections meant signals would either blow up into total nonsense or just vanish into nothing. That's the instability that causes those incredibly expensive training failures we talked about. And this is where DeepSeek comes into the story. They looked at this crashed superhighway of hyperconnections, and they didn't just scrap the whole idea. No, they came up with an incredibly elegant fix. Their big idea was actually pretty simple, which is what makes it so smart. They basically said, hey, the multi-lane highway is a great idea. It just needs some rules of the road. We need a system to manage the flow of traffic so we can prevent all those pileups and crashes. And that is exactly what mHC, or Manifold-Constrained Hyper-Connections, does. It keeps that awesome multi-lane design, but it puts some clever math in place to constrain how the information can mix between the lanes. It basically forces the connections to behave themselves, which brings back this really important property called identity mapping. In our highway analogy, this is like having a strict rule that says a red car entering a lane has to be the exact same red car when it comes out the other side. That stops the signals from getting scrambled into gibberish or just fading away. And while this image just shows it perfectly, on the left, you've got the chaos of the old HC method. Signals are flying everywhere, mixing in ways that can lead to totally unpredictable, explosive results. But on the right, with mHC, you see order, you see control. The connections are constrained, keeping the information flowing in a stable, predictable way. That's the smart traffic control in action. Okay, you're saying, but does it actually work? Well, the proof is in the pudding. Just look at these numbers from their paper. They compared a standard model, the unstable HELC model, and their new mHLC model. And on these really tough reasoning tests like BBH and DROP, mHLC doesn't just beat the baseline, it blows past the more powerful but unstable HLC approach. It's getting all the performance benefits with none of the meltdowns. So who cares about a few extra points on a benchmark, right? Well, this is way, way bigger than that. Having a stable and more powerful architecture isn't just an improvement. It's a breakthrough that could seriously change the entire AI industry. Here's the bottom line. For the longest time, the AI race has been all about brute force. Whichever company had the most money to buy the most GPUs could build the biggest model, and that's how you won. DeepSeek is proving that you don't necessarily need the biggest wallet anymore. You can win with the cleverest idea. And think about what happens when clever engineering starts to beat brute force. Everything changes. All of a sudden, training becomes cheaper, way more efficient. We stop wasting all this energy and money on failed training runs. But most importantly, it could level the playing field. It might actually allow smaller developers, the startups, the little guys without billions in funding, to get in the game and build their own cutting-edge AI. This could be a huge step toward democratizing AI. Now, of course, whenever a paper this big drops, the internet does what it does best. It goes absolutely wild trying to figure it all out. And the reactions to this have been fascinating. They range from these brilliant technical breakdowns to some truly out there theories. First up, you've got this awesome Explain Like I'm 5 from a Redditor named J00Cipher who just nails it. They said it's about allowing multiple logic lanes, but making sure the mixing is happening in a very controlled new way. I mean, that's a perfect summary. Then, of course, you have users who immediately jump to the geopolitical angle. This person points out that a method that needs less raw computing power could be a really smart strategic move for China, potentially making them less reliant on high-end chips from companies like NVIDIA, which are, as they point out, a huge part of the US tech market. And then you get the really weird stuff, the rabbit holes. This user suggests connecting the advanced math in the paper to academics named in the Epstein files. Now, let's be super clear. There is zero evidence for any of this, but we're showing it to you just to illustrate how intense and far-reaching the speculation around a breakthrough like this can get. It tells you people think this is a really big deal, which really brings us back to where we started. After all the technical stuff, the benchmarks, and the wild internet theories, it all boils down to this one central question. For years, the path forward in AI seemed to be paved with more and more silicon, more computing power. But maybe, just maybe, DeepSeek's work is telling us that the next great leap in artificial intelligence won't come from a bigger supercomputer, but from a better idea.